Okay, the last video for this section and for this chapter is dividing complex numbers. Okay? So for example, write in standard form 3 plus 5i over 2i. Well, this is a lot like what we did with square roots. I is a square root of negative 1, so your methods here are much like with square roots. So what you can do is multiply the top and bottom. You might think it by I. That's fine. You can multiply the top and bottom by I, but remember I squared is negative 1, so you'd end up with a negative down here, and then you'd have to bring the negative out and change the signs up here and stuff. It's actually easier to multiply by negative I. Why negative I? Because negative I times I is 1. I times I is negative 1, so negative I times I is 1. Right, so that's the easiest way to do these. Okay, so that's an important thing to remember. Negative I times I is 1. So I'm just going to multiply the top and bottom here by negative I. Right, and on top I get minus 3i plus 5 times 1. Remember, negative I times I is 1, so that's just 5 there. And negative I times I is 1, so that's just 2 on the bottom. So you get this, and then you're supposed to write it in standard form, which is a plus bi. So I need to write it as 5 halves plus minus 3 halves I. Right, the b is negative 3 halves. Okay, so I just divided the first and second term of the complex number, divided each one by 2. Right, that's that. Write in standard form. So that's if you have a single term that's imaginary on the bottom, pure imaginary. This is a complex number that's not pure imaginary, so it has a non-zero real part. Now, how do you do this? Well, it's a lot like when you're rationalizing denominators with two terms, right? You multiply by the conjugate on the top and bottom. The conjugate of 1 plus 3i, which is 1 minus 3i. Okay, so multiply numerator and denominator by the conjugate of the denominator. Okay, so that should sound familiar. In this case, it's a complex conjugate. So that's a complex conjugate, right? 1 minus 3i times 1 plus 3i. And remember what that denominator will be. It will be the real part squared plus the imaginary part squared. The imaginary part is 3. So I multiplied out the numerator, just multiplying each term by each term. I took 5 times 1, right? 5 times negative 3i, which is negative 5 3i. Negative 2i times 1. Negative 2i times negative 3i is plus 6i squared, right? And then on the bottom, I just get 1 plus 9. 1 squared plus 3 squared. 1 plus 9, which is 10. That's nice. So the difference of two squares with I squared equals minus 1 actually gives you the sum of two squares of the two squares being the square of the real part, or the square of the real part plus the square of the imaginary part. So I just multiplied out these numbers in each term, and I wrote the real ones first. So 5, and this is minus, what happened? 5 minus 15i minus 2i is minus 17i. Oh, I didn't multiply the 2 times the 3 for some reason. So that's a 6 there, right? So 5 minus 6 is minus 1, or negative 1, minus 17I over 10. And then you just divide each one by 10. And you can, since it's divided by 10, you can write them in decimal form, right? So negative 0.1 minus 1.7I. And that's the answer. So that's it for that chapter. Ta-da!